Hello, welcome to the Google Search Engine workshop at the GeoPython Conference. I'm your host of this workshop, Chusen Wu, and my co-host is Ko Market. So in this workshop, we are going to talk about Google's engine and geemap for interactive mapping and analysis of geospatial big data sets. Next, I'm going to show you how to get access to the workshop material. You can go to the URL geemap.org and then scroll down to the bottom here, click workshops, GeoPython 2021, and then upper right corner here, click the download notebook icon, and you can download this one to your computer. So for example, I'm going to download to my downloads directory and just click save. Now you should have the notebook example on your computer. Let me delete my other files just to clean up my directory. Once you have this file, and so this is the Jupyter notebook. For those of you who are not familiar, it's basically just a notebook that you can have source code and outputs together, so you can have run code interactively within the Jupyter environment. And next, I'm going to show you how to set up the environment so that we can run this notebook. And before we get into the details, I want to quickly point you to some of the links that might be useful. So if you are not familiar with Google's engine, you can click the link here to go to the Google's engine website. And so Google's engine is a cloud computing platform provided by Google. It's free for research, education, and non-profit. You can sign up for a Google's engine account. You just need to click here, sign up. If you have a edu email, then I highly recommend that you use your edu email to sign up. Usually it's instant approval. If you use your Gmail, sometimes it might take a couple of days to verify your identity. So sometimes you might not be approved for the account. And once you have the account approved, then you can come back to follow this workshop. The next one here is the geemap.org. So this is the website actually we're looking at right now. And the geemap Python package is the one I developed during the past year. It was released, I think, in March 2020. And so during the past year, I have added a lot of functions to the package and makes it much easier to use Google's engine within the Jupyter notebook environment. So during this workshop, we're going to use some of those many functionalities that I developed for the package. You can also check out the link to the Google's engine Python tutorials on YouTube. So far I have developed 55 videos with a total length of 15 hours. I also have the other course here, Spatial Data Management with Google's engine, also 19 videos with 9 hours. So this workshop is only 1.5 hours, and it's basically a condensed version of some of those videos that I recorded before, and hopefully we get to know some of the useful tools that you can utilize to do cloud computing with Google's engine. If you have any questions, you can click the link here to post questions on GitHub. So ask geemap questions on GitHub. As you can see from here, a lot of people actually use this forum to ask questions, and most of those get resolved pretty quickly. So if at any time if you run into any issues with geemap or the Google Earth Engine Python API, you're welcome to post questions here within this discussion forum. Also, the Google's engine website is very useful. It has a lot of, for example, the dataset and also documentation. So if you're new to Google's engine, you might want to look at the documentation. Keep that in mind, the Google Earth Engine documentation, most of the examples were written using JavaScript. Okay, so Google's engine has both JavaScript and Python, and JavaScript has both. You can do basically it has two components, computing and visualization. So JavaScript has both but Python, most of the functions provided is for computation. It has very limited functionality for visualizing the results or dataset, and this is why I developed the geemap Python package to make it easier for you to utilize the Jupyter ecosystem, that you can visualize the data. You can also do all kind of analysis interactively, and we're going to use many of those tools in this workshop. Okay, so next, besides sign up for the Google Search Engine account, you also need to have either Anaconda or Miniconda on your computer. If you don't have either of those, I highly recommend that you just install Miniconda. So you can just click the link, and from here to download the installer based on your operating system. If you're using Windows, you can download, for example, any of those, 3.9 or 3.8, either one is fine. You can, for example, click the download the 64-bit, then just follow the instruction to install the Miniconda on your computer. After you install Miniconda, then on your start menu, you should be able to find a menu called Anaconda 64-bit, and then you can click the icon to just open Anaconda prompt. Okay, so once it's open, so next we can create the Conda environment so that we can install some packages that we're going to use in this workshop. Okay, so let me go back to this notebook, and I already show you some of the commands that you need in order to set up the Conda environment. You can simply just copy and paste, and I'm going to show you step by step. So Conda create, we are going to create an environment named Geo, and then install the Python 3.8, and just hit enter. Then type Y. It might take a couple of seconds to download all the packages. Next, we need to activate the Conda environment, and you just need to right click, so it will automatically paste the command into your command window. Geo, and hit enter. So once you activate the Conda environment, on the left here you should see this one. So Geo, so is the Conda environment that we're going to install the packages. Next, copy this line. Right click, copy, and then paste, hit enter. We're going to install the geemap Python package from the Conda Force channel. So this one sometimes might take a couple minutes because it has some dependencies, and you just type Y. Okay, because I installed the package before and it's using some of the cache on my computer, so it's much faster. But if you're the first time, this might take maybe 3 or 4 minutes to install all the dependencies. Once you install geemap, we also want to install some Jupyter notebook extensions, because this notebook, as you can see here, is a very long notebook, and we're going to utilize some of the Jupyter notebook extension to navigate the notebook, so it will make our work much easier and productive. So next, just copy this line, right click, and then come here, copy, right click, enter. This one is going to install all the Jupyter notebook extensions, and highly recommend also copy the last line. Sometimes it might not work correctly, so just type enter. You should install all the extension, and so last one is to install the extension to our user, and right click, hit enter. Okay, so we have successfully installed all the required packages that we need for this workshop. And next, you need to download the notebook to your computer, the Jupyter notebook. So if you have not done so, click the notebook icon and then download to any directory you want. So in my case, here the notebook is under my downloads folder. So next, you can just type cd downloads. So get into the downloads folder, then just type Jupyter notebook. So this is for Windows. If you're using Mac or Linux computer, you can open your terminal and then similarly just copy and paste those commands to install the packages and set up the conda environment that we need for this workshop. Okay, so next, just type Jupyter Notebook, hit enter. It's open Jupyter Notebook within your browser, and let me right click, close those tabs. So next, once the Jupyter Notebook interface is open, click the MB extension. So this is all the Jupyter Notebook extensions. From here, you can choose some of the extensions that you want to use. For example, there's one table of content. You can Control F and then just table. Okay, you might want to click this one, table of contents 2. And you might also have this one already activated, so the voila. And the other one might be useful is the high input all. And so these are some of the common ones that you can utilize. We're going to use this one, table content, because the notebook example is very long, so it would be nice to have the table of content. Okay, so next, go back to files and then just click here the notebook to open the notebook. Once it's open, by default you should be able to see the table of contents. So this is the one that coming from the Jupyter Notebook extension. If you don't install the extension, you might not see this one. And so you can click this one to show and hide the table of content. You can also have this one is to hide all the output or all the source code, right? So if you click this one, it's going to show you all the source code. If you click again, it's going to hide. Also the voila. So the voila is the package we're going to use later in this in this workshop. So but for now, this just leave it as it is. Okay, so next, let's go back to the top of this notebook. You can also slightly move this one to the left if you want. So once we have all the environment set up, then we can start going through the examples. But before we get into the details about this workshop, I want to give you a quick overview of Google's engine. So if you're not familiar with Google's engine, it's a cloud computing platform, and it has a huge data catalog. So you can click the link here to go to the website, the Google's engine website. So once you're on the web page, you can click the Datasets. Google's engine has a huge data catalog, over 35 petabytes. So you can just here, you can type a keywords here and just to search any data set you want. For example, elevation or land cover, land use, weather, climate data, whatever data you want, and just click. Then search. You should be able to find the data set and for find the data set that you need. Also, you can go to the documentation to look at some of the example. If you want to know more details about Google's engine, I highly recommend that you go to the documentation webpage. Although most of the example were developed for JavaScript, but most of the syntax are very similar for both JavaScript and Python. So you click here, and then especially this section, objects and meshes. If you want to get into the details about how the terminology of Google's engine, then you need to be familiar with this. For example, image collection, geometry, feature, and feature collection. So those are some of the very important ones. Because this workshop is only 1.5 hours, we won't be able to get into all the details of this. But I highly recommend that you check this out and to learn more about Google's engine. Okay, so let's get back to the Jupyter Notebook example. So we're going to go through here. In this example, we have a notebook example. We have 8 sections, and so we're going to go through one by one to show you how to get started, how to basically how to load it, how to create an interactive map, how to use Google's engine dataset, and to do visualization and analysis. And lastly, you can also create some maps for journal publications or for a technical report. You can also export data to your local computer. At the end, if you want to publish your data product, you can develop interactive web app to be hosted on your local computer or on a server. So this is kind of walk you through the entire workflow for using Google's engine and GeeMap. Okay, so let's get started. Since we already have everything set up correctly, then we should be able to go through the novel example. So first, you need to import the library. So in this case, we're going to import the Google's engine Python API and also GeeMap. We also import the Python built-in library OS, because we sometimes need to export the data, need to save the data to your computer. So all you need to do, you can press Shift Enter on your keyboard to execute this the notebook, or you can simply just click Run. So it will be very similar. So you can click, if you can either use your mouse or you can use your keyboard. And after that, we just need to create an interactive map. So it's very easy. Just geemap.map and then parentheses. Keep in mind the map here is uppercase, and you can save this one to as a variable map. The reason we're using this is that we want to be consistent with the JavaScript API, because the JavaScript API by default, the map is called uppercase map. So, and then just Shift Enter, you should be able to see this interactive map. So this is just the base map, built on top of IPyLiblet. And on the left here, you should be able to have this, for example, this icon to source data. I'm going to show you later. On the right here, you can also have, for example, the toolbar. And by the way, this one looks like it's not the most updated yet. So maybe let me show you how to actually to update the package to the latest version. So if you see, for example, this one, see the just 2 columns, that means your package is not up to date. And what you can do is to, for example, here, select this one and then cell or insert cell below. Okay, so from here you can just type geemap doc and then just hit tab on your keyboard to bring up this one, and then just update, and then select update package parentheses. Okay, and then just Shift Enter to execute this one. So basically, this one is trying to download the package from the GitHub repository and then install the latest version to your computer, because the package is being actively developed, and some of the new functions that are being added daily, so you might not have the latest version. But if you run this one, you should be able to update to the latest version. Okay, so once you execute this one, you want to use Control/ to comment out this one, because you only need to update this once. And after that, just kernel, restart kernel, and clear output. Okay, so and then we can run this one more time. Run and run, create the interactive map. So this time you should see this one. Right now we have 3 columns of 2 bars, and that means this is the most up to date version of the GeeMap. Okay, so as you can see, it's pretty simple. If you want to create an interactive map, you can just use geemap.map. Then you have this map. You can also you can customize the default map. For example, you can choose the center. So by default, it's centered around the US, and the zoom level is 4. But you are welcome to choose to other locations. So this is the latitude and this is the longitude. So don't be confused. Sometimes you might be longitude, latitude. So it should be lat long. Okay, and then the zoom level, you can also choose the light mode. If you, for example, here you have too many toolbars, you don't like that, you can just simply choose this one and then just run. You should be able to create an interactive map with just 2 buttons here: zoom out and zoom in and zoom out. And then you can use your mouse mouse wheel to scroll to zoom in and zoom out the map. Okay, so this is how you can create the interactive map. You can also add some base map. For example, also just want to let you know, because for most of the examples, each section we create a map. But in the real applications, you don't need to create so many maps. You just need one map, and then you can display the map at multiple locations. So in this case, I'm just going to create another map, and then I add the base map called hybrid. So hybrid is a Google satellite base map with labels, so it's called hybrid. So you can just hit run. As you can see, now you can have this base map here, and you can click here, click the toolbar icon, and then the second one here, layers. So here you can turn the layer on and off. Okay, you can also change the layer opacity if you want. You can just slide this this one here. You can also turn all the layer on and off if you have many layers. So this is how you can add the base map. There are a number of base maps available. So if you want to see what kind of base map available, you can import the base map module. And so once you import the base map module, then you can use the base map module to auto complete. So you just type, for example, base maps dot, and then hit press tab on your keyboard. It's automatically pop up the list, so you can select from the list here, select some of the existing base map available in the geemap package. So for example, I can just select this one, open topo map, right? And then again, shift enter. It should load the base map onto the map. Again, you can click the layers and then you can turn the layer on and off. So this is how you can create a map and also add a base map. Next, I'm going to show you here how to change base map without coding. So again, I'm going to create a new map. And here, right, we click the base map. So this is by default, we added the Google base map. But there's a toolbar here. If you click this one, this map icon, and then from here you should be able to select from the drop down list. So basically you can change the base map without coding. You can select any base map you like, for example, terrain, hybrid. Okay, so the hybrid is the one with the Google satellite with base map labels, and you're welcome to select any other one. For example, Esri shaded relief, and for example, there's so many examples you can choose from. And if you have any other base map that you like, you can submit a feature request on the geemap GitHub repository. I will be happy to incorporate some new base maps into the package. Besides adding the base map for from this existing one, you can also customize, adding some custom WNS and XYZ tile layers. If you want to find some examples, you can go to the link here. For example, the national map. Here, this website has tons of web services you can utilize, and you just need to click. Then from here, you will see, for example, WMS. You will need this one, so WMS or XYZ. So if you click any of those, for example, hydrography, and then open the link, you should be able to find this one. So WMS server. So this is the link that you can copy and then come back to here, just like this. Okay. So the first one here, the first example, this one is the XYZ tile layer, and this one is from, for example, Google Terrain. You just hit one, is create a new one. So this one here is the terrain layer, right? So the default one here is the Google map, but we added the terrain. If you have any XYZ tile layer from, if you know the URL, you can just pass the URL and then add that one to the map. Similarly, you can, the second one here is WMS. So add WMS layer, you just need to have the link. Okay, so once you have the link, then you can just use the add WMS layer to load the data onto the map. So this is the 1 meter resolution map imagery. So this is a huge data set. And if you already know the WMS, you just need to load this. You don't need to download any data set. So similarly, you can go to this website to find some other WMS services, and then you can load that one to the map if you want. So for example, let me find this one here, shaded shaded relief, and you need to copy, for example, this URL and come to here. You might be just to replace this one, paste. You also might need to maybe change the change the name. Okay, so for example, shaded relief, and then shift enter. Okay, so you should be able to see this one being loaded, right? This is at the global scale, and you can see the map here. Okay, so this is how you can bring in base map layers from the internet. From you can, this can be from a local server, it can be from any web server, as long as it use the same protocol, either XYZ or WMS layers. Next, let me show you here is to use the drawing tools, because most of the time if you have the map, sometimes you might need to draw some ROI on the map, and so the geemap package has some built-in tools that are from IPyLiblet. So if you can create the map, and then you can simply draw a rectangle or a polygon on the map, or even circle or line. So for example, so this is toolbar where you can select this, and once you, for example, once you draw those polygons, you can actually have access to the Google's engine object. Once you draw those regions of interest, they are being converted to Google's engine object, so they can later use those in your computation. So how do you get access to this polygon, right? You can control slash to uncomment this one. So the object is stored within the attribute user ROI. So user underscore ROI. If you shift enter, you should be able to see this one. So this is basically a JSON format, and it's not very useful in if you're using Python. If you want to see the real content, you always need to use the dot get info parentheses and then control enter. You should see this one. So this is, for example, this is the user ROI is the last object that you draw on the map. Okay, so this is basically a polygon with 6 points. Also, you can have access to all the polygons. So it's named user ROIS get info. So in this case, we have 2 polygons, right? Let me draw another one here. So we have a total of 3 ROIs. And if you run this one again, it's changed. So now it's being changed to this one. But if you want to get access to all of them, you use this one, user ROIs. And if you scroll down, right, you should be able to see 3 features, right? The first one, the second one, and the third one. Okay, so this is how you can access to the shapes that you draw on the map. And you might be able to use this to do filtering of Earth Engine data catalog if you want. So this is how some of the tools for the geemap. Next, I'm going to show you here how you can convert Google's Engine JavaScript to Python. So for those of you, if you're already familiar with the JavaScript and you want to try out Python, then you might need to convert your script from JavaScript to Python. Actually, right now the geemap Python package has those things built in, so it's actually very easy to do. There are 2 ways you can convert the JavaScript. You can either use just assign whatever JavaScript here to a new variable and then wrap them with 3 double quotes. So you can go to the Google's Engine website and you can copy any script. For example, you can just simply copy this one and then come back to here. You just simply paste your content here. It can be any script and just execute. After that, you can call the function geemap JS snippet to Python, and you can pass in this variable at the new cell equal to 2. That means we're going to generate a new code block with the Python script, and you can either want to import or you can just use those default and just hit run. Then you should be able to see this one. So this is the script that has been automatically converted from JavaScript to Python. Then you can just shift enter to execute this one, right? So you should be able to see the similar result that you see from the JavaScript. So this shows you a way to easily convert Google's Engine JavaScript to Python. Besides using this way, there's an easier way that you can directly use the toolbar. So what you need to do, you can create a new map, right? So once you have the new map, then you can click the tool icon and then click this one. Okay, so once you have this, it's going to pop up this dialog. Then you can just copy and paste any Python script from the Earth Engine documentation website. For example, you can copy this one, or you can find any other one you like. So for example, for this one, I can just simply copy this, then come back to the notebook. Okay, right click, Control V to paste this, and then just click convert. Okay, it's going to convert this one into Python script. Then just hit run. You should be able to see the data being loaded here to the map, right? And then you can use the layers icon to turn the layer on and off, or even change the layer opacity. So this is how you can convert Google Earth Engine JavaScript to Python. Okay, so the first section just basically introduce some geemap basics, and the next section is about Google Earth Engine datasets, because in order to do computation, you will need dataset, and you will need to know how to access the Google Earth Engine data catalog. It's very, very important. So next, let's go through this example. How we can load the dataset. So every dataset in the Google Earth Engine data catalog is a unique ID. For example, this is for the USGS DM, and so it's within the ID, it is either single quote or double quotes, but it needs to be wrapped within the Earth Engine image, or for example visual collection. So this is basically a raster dataset, just one single image. Sometimes you might have a stack of images that would be called image collection. So if you want to learn more, you can go to the Google Earth Engine website to learn more about those. But for this simple example, we're just going to add the data. Let me just execute first. You'll be able to see the results, right? So we have three raster data layers: Earth Engine image, a DM, lane cover dataset, lane set, and also vector dataset as visual collection for the US states. Then you can set the visualization parameters. So this is basically telling Google Earth Engine how you want to visualize the dataset. And for example, this is for the elevation dataset, the minimum, the maximum, and also the palettes. If you have used some desktop GS, for example, ArcGIS or QGIS, then you might be familiar with this. Basically, you need to, if you want to visualize the layer, you can set up, for example, the range of the values, minimum, maximum, and also what color you want to use to visualize. After that, you can just use map.add_layer. So within here, you can press Shift Tab on your keyboard to bring up the function definition. So again, within the parentheses, Shift Tab, and then from here you should be able to see the function definition, what parameter you need to provide, and also some of the default values. So this might be useful if you are not familiar with the function. For example, for this add layer function, we have 5 parameters. So the first one here is the object. The second one is the visualization parameters, and then the name of the layer, and whether you want to show the layer by default or not, and also the opacity. So this is the one, right? The Earth Engine object, the visualization parameters, the name of the layer, show or not, and also the opacity. So we have these 4 data layers, and this is how you can visualize the data layers. On the right here, if you click this icon to turn the layer, you can turn all the layer off and then just turn them on individually, right? So the second one here, this is the DM. You can change the layer opacity if you want, from the left to the right. And this one is the lane cover, also the lane set data. And last one here is the vector data set, right? So this is how you can load the data onto the map. But in order to load the data, you might need to know the ID. Sometimes if you just if you're new to Google Earth Engine, you might not know where, okay, how do I find these IDs? You have no idea. Then here you need to search the Earth Engine data catalog, right? So you can either go to the Google Earth Engine website, and click the dataset tab. From here, you can search any dataset, or you can scroll down, for example, to any section and then click. And then if you navigate, you continue to click in. Click. You should be able to find here the unique ID. So this is an image collection. Basically, it's a stack of images, right? Just think about on your computer, you have a directory. Within your directory, you have a lot of images, right? So this is just the name of the directory. In geemap, you can also easily search the Earth Engine data catalog. So what you need to do is to create an interactive map, right? And after that, you can click the left here and then click data. So from here, you can search, you can type any keyword to search the dataset. So for example, elevation, right? And then hit enter. It automatically go to the Earth Engine data catalog to search the dataset, and you should be able to see here the list of all the dataset that has the elevation tag. Or you can just simply select from any of the list. For example, I can select SRTM digital elevation. Once you select the dataset from the drop-down list, then you should be able to see, for example, the thumbnail, also the Earth Engine snippet. And if you want, you can click the link here to go to the Earth Engine webpage to look for more information. After that, okay, let me do this one more time. Elevation, and then select from the list SRTM. You can just simply click the import button. So if you click the import, it's going to import these two lines into the notebook, right? So this is basically easy way that if you don't know the ID, it's automatically going to create this one for you, and then you can directly load the data onto the map. You can also change the variable, because by default all the variable will be dataset underscore and then 3 random characters, and this might not be what you want. You can change to any other name you like, but make sure that you also change the name here when you add the data layer. So okay, so since I already have this line, I change to DM. I can just delete this one, and then just shift enter to add this one to the map. By default, if you don't pass in the visualization parameters, it will just grayscale, so it will just look like this, and this is not very helpful because you cannot really see anything from this grayscale image. So it'd be nice to if you want to see to have a visualization parameters, you can customize minimum, maximum, and then you can pass in the visualization parameters in this function. So and then shift enter again. You should be able to see this is much better compared to the default visualization. Besides searching the Earth Engine data catalog, you can also use the datasets module within the geemap package. So all we need to do is just to import the datasets, and then so I'm going to shift enter. Once you create the import the dataset module, then you can use the dataset to find the data with auto completion. So all you need to do is just data dot, and then press tab tab on your keyboard. It will bring up the list. So here you should be able to see the entire Earth Engine data catalog, all the lists, and you can choose any data set you like, right? So it's very easy to do. For example, if you here, you can do maybe try, for example, USGS, and just hit tab again, right? You can scroll down to find any data set you like. For example, any DM. So you scroll down. Is there any DM you like? So maybe let's find which one. Topo 30. Or this one, right? A*TM. Similarly, you can specify the visualization parameters, and then you can add the data layer to the map. And then shift enter. Very similar. You should have this one loaded to the map. So this is how you can easily source the Earth Engine data catalog and load data to the interactive map. Lastly, you might want to use the inspector tool, right? So because Earth Engine, everything just from the Earth Engine data catalog being streamed to your computer in real time. So, but you might want to, for example, query the dataset. You want to get the pixel values. You want to get the polygon attribute. This is how you can use the inspector tool. So this is the first icon here in the toolbar, and I'm going to create this notebook example. This sample dataset here. Then click the icon, click the inspector. Then you can click on the map anywhere on the map to query the Earth Engine dataset. Click mine. So this is when you click your mouse on the map, it's going to get your mouse coordinates and then send the coordinate to Google's engine to do the query and then return the results showing up here in this dialog box. So if you click other location, you will see here we have 4 layers, right? Elevation, land cover, landscape data, and US states. You click outside, there's no polygon data set, so you only have the raster. You can also turn the layer off. For example, if you are not interested in, for example, the US states or the land cover, or even the landscape data, you just want the DM, then you can turn the other data layer off. And then if you click on the map, it will only show you the visible data layers. You can also look at the coordinates, for example, the longitude and latitude, also the pixel resolution, right? So this is when you are zoom, you can also zoom out and zoom in. The pixel resolution will be will decrease. So, and this is how you can use the inspector to query the Earth Engine, all the Earth Engine dataset that you loaded to the map. Okay, so this is the inspector tool. You can do it for any vector dataset or raster dataset you want. Okay, so this is for the section 3 Earth Engine dataset. Next one, I'm going to show you here how to do some visualization. Okay, so you can, depends on the application requirement. The geemap here provide a couple of tools there for you to visualize the dataset interactively. The first one here we're going to introduce is the plotting tool, right? And it's the second icon in the toolbar. Again, I'm going to load some sample dataset. So this one here, we're going to use landscape data and also Hyperion hyperspectral data. Once the map is loaded, you can click here to take a look at the data layers, right? So the landscape, global scale, and also the Hyperion. Then you can click the plotting tool, right? So from here, you can select what data layer you want to do the plotting. If you, for the first one here is landscape, and then you just click your mouse on the map, it should create an interactive plot, right? So we have this is the spectral signature. We have we have 6 spectral bands in here, and from B1 all the way to B7. If you click, for example, water, you should get the different spectral signature. You can inspect any location you like. This is for multispectral data. You can also change to the Hyperion hyperspectral data, and then similarly you can click on the map. You should be able to see this kind of spectral signature. So this one is way more detailed. It has almost 200 bands. Okay, so you can click the map here. Again, this is just for to sample data set that we're using here, but you can use this one to create profile for any raster dataset you want. Next one, you can also change the layer opacity. I think I already showed you this one earlier. It's very easy to do. When you can load the dataset, then you can click the layers icon. Then you can turn this one a slide to the left, to the right to change the layer opacity. You can either also change the base map layer. So all the layers right now loaded into the map layer, all kind of interactive widgets. So you can change them interactively if you want. Also, you can visualize raster and vector data easily. For example, let's take a look at this one here. And if you click, right, so this one right now we have 2 data layers, the landscape data and also the DM, right? What you need to do is to go to this one, click the layers, and then click this icon to, you can customize. For example, this is a RGB 3 bands, right? You can also just show just 1 band, and then if you click this one, From the drop down list, you can select what kind of band you want. You just hit apply. It will just show you one spectral band. So if you want to change to different band combination, for example, I can change to B5, B4, and B3. Hit apply. Then you should be able to see this one. You can also change the opacity, or you can change the range. You can also change the gamma if you want. This everything can be customized. So this gives you a quick way to visualize raster dataset without having to write any line of code. You can also click the import. It's going to automatically create the visualization parameter so that you can utilize this in your source code, so that you don't need to use the interface if you don't want to. So you can just click close. So this is for the multispectral data. You can also do that for a single band. In this case, we are using the DM, and you can click this one here. By default, it's going to use the visualization parameters that you already provide for the data layer, but you are welcome to customize. So in here, you can select, for example, how many classes you want. If you don't select by default, is some of the classes might be 255. You can also, on the right here, you can choose the color map. So you can select any color map you like. Let me try here. I'm going to use the terrain. It's going to change, and then just hit apply. It should be changed. You can also change the palette, because this one here, if you scroll to the right, you have a lot of palettes, right? Sometimes you might not need like many. You can choose, for example, 12. You apply. You very much similar. You can change, for example, to other data layers. I can change to maybe try this one, GSOs. You apply. Right, and you can also change the gamma, change the opacity. Everything can be easily customized. So this is how you can visualize dataset using the interactive GUI. So next one, I'm going to show you how to visualize vector data. So you just execute. So this is the vector data, the state polygon for the US, and you can similarly click the layers icon and then click this one. So here you should be able to customize the vector symbology. For example, by default, it's using the black color outline, and also fill the color with some kind of transparency. You can change here, for example, the outline color maybe to red color, and you can change the opacity to 0. It's going to show you just the outline. If you want, you can change the opacity. You can change the fill color maybe to blue color, and just hit apply. That's it. Very simple and easy to do. You can also style by attribute. For example, you might want to create a map that style the attribute based on a certain attribute values. You can click this one, and it's going to show you, for example, the columns available in the attribute table. I can select, for example, name, and then from here you can select, for example, this just shows you the column values. You just need to easily just hit apply. Very simple to do. You can change, for example, to region, right? So this one has 5 values. You might want to have 5 classes, and then you can just hit apply. You can change the opacity, right? Different color, different region here in the US. If you want to add a legend, you can also add a legend. You can just click this one, and then you can change this, for example, class 1 to you can change the text, and after that just hit apply. You will see here is this one is being added. So it will show you, for example, class 1, this one. If you change the text, this, for example, northeast, and then midwest, or south, something like that. So this is how you can easily customize the vector data set. You can also, for example, turn the layer on and off. Keep in mind, the legend is tied to the layer. So if you turn the layer off, the legend will also be turned off. And that one is using the interface, but there's also a function add style vector. So if you have a vector dataset, you can also provide the visualization parameters and also the palette. So in that case, you don't have to use the interface. So this is just make you, it's more precise that how you want to visualize the dataset. Okay, so if you use this way, you will see this one is being loaded to the map. So this is how you can customize the symbology to whatever way you want. You can use this using the style function, what column you want to use, and how you want the color to be used. Next, I'm gonna show you how to add a legend. Right, you can. There are lots of legends that you can add to the map. Sometimes if your map is a semantic map that you want the user to know like what each color represent, then you might want to add a legend, right? So Google's engine or Gmap has some built-in legends. If you want to know what kind of built-in available, you can execute this code block to see some of those common ones. For example, the NLCD and also some MODIS dataset. So next here, this is example how you can add, for example, the NLCD dataset, and also just use the add legend function, and then just passing the built-in legend NLCD, you should be able to see the legend. So this is very easy to do, right? Here, and once you have the legend, then you can use the inspector tool. You can click on the map. You should be able to see, for example, the lane cover classes, for example, 82, 95. Then you can scroll down to see, for example, 95 represent what classes. You can click on the map. So this is very useful, especially if you are working on some lane use, lane cover dataset. You might want to add the legend. Besides the built-in, if you have your custom lane cover dataset that is not the standard one like NLCD, you can also add your custom legends. All you need to do is to create a dictionary, and the dictionary has values, and also this is for the label. The label going to show here on the legend, and also the color. So the color is the one here on the left. This rectangle showing you the color. So I'm just going to execute, and these two looks pretty much exactly the same. This one used the built-in, but this one used the custom legend that you can provide a color and also the label. And you might want to use this one if your dataset is not the standard lane cover product. Besides adding a legend, right? This is basically categorical data. You can also add a color bar for continuous data, especially for elevation and surface temperature, something like that. So first, let's create a default map, and this is how you can add a color bar. So color bar, and you just need to pass in the visualization parameters. So the visualization parameters, you can have a minimum, you can have a maximum, you can also have a palette. So those things we want to utilize to create something like this. You can have this color bar here on the map, right? If you turn the layer off, the color bar will also be turned off. By default, it's being added to the lower right corner, and you also have a background, but you are welcome to customize. For example, if you want your color bar to be vertical, you just need to add the orientation parameter to vertical. And if I can execute again, you should be able to see this one at the lower right corner here. You can also change the background to transparent. So passing the transparent background equal to true, control enter. So this one, it might be because my iPad leaflet is not most up to date, so the transparent might not work as expected. But if you update your iPad leaflet to the latest version, you will support the transparent background. Similarly, you can use the discrete, right? So this is the continuous color bar, but you can use the discrete parameter to create discrete color bar, just like this, right? So if you map indeed it has discrete multiple categories, then you can create something like this easily. Okay, so this is some of the basic tools you can use to visualize dataset. And so the next one here is some of the tools that you might use to create some split panel map, especially if you want to compare some dataset before and after some event, for example, natural disaster. So you can just use the function split map and then passing the left layer and right layer. If you're just passing a string, those can be something from the base map. So if it is available, then you can use it, for example, set type base map and the Google map. And this is very nice for you to compare the result. Besides those, for example, Google map, you can also use the NLCD, right? So NLCD, for example, 2016 and 2000 and 2001. So this is how you can visualize the result. If you zoom to some location with geometric changes, for example, this is I think near Las Vegas, right? So if you see from 2001 to 2016, some of the urban expansion and also the water dynamics. So this one here is just simply the base map layer, but you can also load a Google Earth Engine dataset. So it has two layers, but you need to convert Earth Engine dataset to a tile layer. So after that, you can pass in those two layers into the map here as the parameter, and visually look exactly the same. But this one right now, the dataset come from the Google Engine data catalog, okay, directly, and this one here, the dataset come from the USGS WMS web service. So although they look very similar, but behind the scene they are very different. Besides creating the split panel map, sometimes if you want to have more, you might want to create link maps. So in this case, we're going to create a 2x2 link maps, and behind the dataset is using the Sentinel-2, but you can have different band combination, for example, natural color and land water. So this is how you can customize, for example, the visualization parameters. This is a list. Within the list, you can pass in how you want to visualize, and all the maps are linked together, so you can easily move. If you move one of those, it's going to move all the other maps. So this is how you can quickly visualize the different combination of bands for a certain image. Okay, so besides creating link maps, you can also create time-lapse animations. So if you want to see the dynamics of the landscape using the Landscape Data Archive, you can easily using geemap to create something like that. So I can show you here. So this is kind of the animation I created. You can just play. You should be able to see, for example, the animation. So this one shows you you can click the toolbar and then you can search any location. Let me maybe change to high quality, and then you just need to draw a rectangle on the map, and you can customize those parameters easily. And you can also change different band combination. You can change the start year, you can change the end year. If you want, you can also create some spectral indices, normalized difference index to visualize the data layers. So this is how you can create animation. Like I said, if you go to, you create any map. So let me show you here. You just press B, it will create a new one, and then just map equal to geemap.map. Okay, so this is the icon, this one here, the globe icon. So if you click this one, and then you should be able to create time-lapse animation for any location around the globe. Next one is create time series composite, because sometimes it might be used to get access to the original Google Earth Engine dataset. For the time lapse here, the one I show you above, that one is just for animation. If you want to have access to the real dataset, then you can use this icon. So the next icon here, this one here, you click this one. This one is creating time series in cloud-free time series image. If, for example, using Modis or using Sentinel or USDA name imagery, it's very easy to do. If you want, you can try it out. Here I also have a short animation showing you how to use these two, and you can click play. Okay, so this is here. You click the toolbar icon, and then you can select from the drop down list. You can also simply draw a rectangle, for example, on the map, and customize the band combinations. All you need to do, you just select this from these options. You can choose the year, you can choose the end year, and then just hit apply. Then you have access to the time series image composite. You can use the time slider to play with the slider, or you can just drag the slider to any year you want. And this is just one easy way that you can create cloud-free imagery without writing any line of code. For example, you can also do that for Sentinel imagery for the same location, right? So the Sentinel imagery is 10-meter resolution, and the Lancet is a 30-meter resolution. So depends on your specific application requirement, you might want to try out different sensors. Also, you can do it for one. If you're in the US, you can also have access to the 1-meter resolution name imagery. Again, you can change the band combination easily, and then to create time series images for your area of interest. Okay, so this is for creating a time series images. And so for the section 4, we talk about how to visualize the dataset and how to change the data opacity, how to add some simple map elements, for example, legend or color bar. Also, how to create link maps so that you can utilize the geemap for interactive mapping. Okay, so the next section is about data analysis. So besides doing visualization, you can also utilize the Google's Engine API to do big data analysis. And first example is about descriptive statistics. So for example, if you are using the Lancet data or whatever raster data set, sometimes it might be useful to look at the minimum, maximum, or the mean standard deviation of a specific band. And then you can use the geemap function called, let's load the dataset first. So this is the Lancet 8 imagery. You can look at, for example, the the properties. So you can utilize the property names and then docker info to get what kind of metadata of this imagery. And once you know, for example, what kind of attribute it has, for example, lane cover, then you can use the .get to look at the lane cover. Geemap has a function image props to give you just a shortcut to get access to all the properties. So you can just hit run and you should be able to see all the value, like all the properties and also the value of that property. So for this specific image, the cloud cover is 0.05, so that means 5%. You can also do image stats. So it's going to, you also need to provide a scale. So to make it faster, we use a smaller scale, 90 meter. And once you execute, you should be able to get, for example, the maximum value of each band from B1 all the way to B7, right? So the value of each individual band, the maximum, the mean, the minimum, and also the standard deviation, also the sum. So this might be useful if you want to take a look at the some descriptive statistics of the dataset. Next one is about zonal statistics. So if you have a vector dataset, you want to calculate some the basic information about each vector polygon with you based on a raster. For example, this is we're using the DM, and we also have a polygon using here is the US state boundary, right? So if you want to calculate, let's say, the minimum elevation of each state, then or the average elevation of each state, then you can use the zonal statistics function within geemap. So you can set the output directory, and you just need to call this function, passing the image and also the vector and where you want to output. In this case, we're trying to calculate the mean and also the scale. So you can first, for demo, I change this to a large number, but you can change this one to a smaller number. And this is, for example, for the DM, right, 30 meter, and it only takes a couple seconds to actually calculate. And the CSV is being downloaded to my computer, and you can open this one to take a look at the CSV. So the mean value, right? So for all the states, you can look at the mean elevation for each one. This is just for one single band. You can also do it for multispectral band, right? So for the Lancet data, we have a multispectral band. You can calculate, for example, the sum of all the pixel DM values within each state, within each polygon. Again, we can open this one, and usability have multiple bands, right? So we can get all the value easily using the zonal statistics function. So this one here is just for one category, because you just treat all the pixels within that polygon as the same. But sometimes you might want to calculate zonal statistics by group. By group means, for example, if you have a lane cover data set, you want to calculate the lane cover composition within each polygon, then you need to use zonal statistics by group. In this case, we are using the NLCD, right? And within the vector here is the US state. In using the zonal statistics by group, you can find out, for example, for within each state, what's the percentage of urban land cover, what's the percentage for agriculture, right? Or other land cover data type. You can easily use this to quickly get some idea about the land use, land cover composition within your study area. Okay, so the data has been downloaded, and we can open and take a look at NLCD CSV. So it depends on how many classes you have in your data set, right? So class 81, and for different state, you will see the total area, or it can be percentage. So it depends on how you set up the function. This one we use the sum, but you can also use percentage if you want, right? So either it's sum or percentage. And this is how you can do zonal statistics by group. The next two example is about supervised classification and unsupervised. So this is kind of a long tutorial. You can go to the geemap Python package if you want to watch the video, because we might not have time to get into the details of all the this classification in here, but I show you some of the basic steps that you need to do in order to do supervised or unsupervised classification, right? So these are some of the simple steps you can follow through, and I can quickly, for example, load the dataset to the map, and then so assume that we are trying to classify this image, right? So once you load the imagery, then you can create some training dataset. So the training dataset, you can specify a region, or by default, if you don't specify, it's going to create training samples within the image polygon. So we can create some random samples, and if you click here, select this one, you should be able to see all the sample, the points, right? So these are all the random points that Google's engine created, and then you can use those random points to create the training data, right? So next, you need to initiate the cluster. So in here we use the k-means, right? So we're gonna, for example, in this image, we're gonna create 5 clusters, and then we're gonna train basically to extract the pixel values for those random points. And after that, you can just classify the images and then add the result to the map. That's it. So once you have the map, this is the unsupervised classification result. You can assign the color. You can label the cluster, because those clusters are random. So if you want to assign fixed color to each one, you can. So what you need to do is to have a legend color and the key, and after that you can add the legend to the map. Right, so once you execute this one, you can change the color. This is just a simple demo, so the color might not be ideal, but you can change the, for example, the name of the cluster. Is it vegetation, urban, or water, something like that. And this is how you can customize easily. You can also change the layer opacity, right? So like in here, if you want, you can, let me turn up the layer, right? And change this to basically overlay the two layers to see the final result. But you can also, if you want, you can create interactive widget just like this one here. You can also change the layer opacity using the IPy widget. It's the same as this one. Lastly, you can export the results. So in this case, so I'm going to export. You can use the EE export image to export the result to your local computer, and then you can set the scale. So length is 30 meter. I choose 90 meter because it will take much shorter time to export the result for a coarser resolution dataset. Okay, so this is for unsupervised classification. The other one is supervised. So this is so-called the classifier. Earlier is the cluster rule, and this step is pretty much very similar. So this goes to the example. Again, we're going to use the same data set. So this is the Lancet 8. After that, you can draw a polygon to create training samples if you want, but you can also, if you already have some existing training sample, you can do that. In this example, we're going to use the NLCD length cover dataset. So we can add the NLCD to the map, and then we can generate some random training samples. In this case, we're going to generate 5,000 training samples. Might not be displayed on the map, so you can turn this one on, and basically we generate the random samples, and then we're going to extract the label, right? Because for supervised classification, we need to have the label, and we use the NLCD as the reference dataset to extract the label, and you also extract the value for the original Lancet spectral band. Then we can use the training samples to as the to train the classifier, and then you can classify the image, right? So again, train the classifier, and lastly classify the image. That's it. So the steps are pretty much similar. We don't have time to go into the details, but you can follow the example here. You can also look at the GeoPython engine documentation to find more details. Once you have the image, then you can set the color, right? So if you want the color to be similar to the one of the NLCD dataset, you can. So you just need to set the properties to the image, and after that you can add the dataset. So right now this is the one. This dataset is the supervised classification that we created. You can compare this one to the, maybe you want to maximize. You can compare this one to the original NLCD, right? So this is the classified length cover. Look at this one. It's not perfect. This is just a demo, but you can have a better training dataset to have a better length cover classification, but it gets the work done easy using Google's engine. Just a couple of seconds, then you can get the classification result done. Again, you can visualize the result. You can also export the result to your computer if needed. Next, I'm going to show you here, you can also create training samples. Earlier, this one is based on random sample. But if you want to manually create labels, you can do that as well. So you can use this toolbar icon here to create. I also have a quick demo here shows you how to create training samples using geemap, right? So if you click the map and then you click the hand icon, then you can easily create, for example, labels. You can change to different color. For example, these are all water, and then you can change, for example, to vegetation. Then you change the color. You draw rectangle or polygons on the map to create the training samples. Later, you will be able to use this training sample to extract pixel values and then to train the classifier if you want. This one is still a work in progress, so I haven't made a tutorial about this yet, but this is just a quick demo showing you how you can create training samples and then you can export the samples to your computer, and then you can open those using other desktop software if you want, right? So in this case, you can export the data as a swap file and then open using QGIS. Okay, so this about data analysis. This is just some simple example. There are a lot more things you can do using Google's engine. More information can be found on the Google's engine documentation webpage. There are a lot more things you can do there. Okay, so next I'm gonna show you how to create some maps, right? So if once you've done all the analysis and visualize the dataset, you might want to create some maps, and it'll be very useful to create some high quality maps that you can use for your journal publication or technical report. So in this case, we're going to use the Kato EE module. So the Kato EE module is was developed by our co-host KO Marcus. So and he integrates the module into the GMap, and now you can directly use GMap to create maps easily. So let me just quickly show you the example. So Kato Pi is not installed yet, and you might need to install this one on your computer. So if you want, I can copy, and then so you need to basically open the Anaconda prompt, and then just conda activate. Activate, and then so geo type this one and then control enter. So this one sometimes might be very challenging to install on Windows computer because I developed this example using my Linux machine. I haven't tested this on Windows, so I'm not quite sure if it will be installed or not. If it doesn't, then you might need to try a different computer. Looks like it's okay, so let's see if it works. Okay, so now the ColourPy package has been successfully installed, and what we need to do is to actually restart the kernel. Restart and clear all outputs. Then you might need to go to the import the libraries again, and then navigate to here to this section and this import this one. Okay, it works, and just execute. Right, so this is how you can create some maps, nice maps using GMap. And you also have the color bar here to the right. This is for at the global scale, but you can also create plot RGB imagery, for example, using the Lancet data, right? So those datasets come from the Google's engine dataset. So let me execute, and we can take a look here. Okay, so you can also add coordinate grid to the map, right? So you can have the labels, you can have a north arrow, and you can also have a scale bar. So and this is the package right now is still being developed. Right now it's very basic, but in the future we might have more complicated scale bar. besides editing this, you can also add, for example, a legend, right? I can show you here. This is a little bit more complicated, but you can just follow the example and then customize your dataset and then change those parameters to get the map you want, right? So in this case, we added a legend to the map. You can have a coastline, you can have a city on the map. You can have multiple data layers if you want. So this is how you can quickly create a map like this. Lastly, you can also plot multiple maps, right? So if you have multiple data layers, you have a raster layer, you have vector data layers, you can combine them all together to create something. Okay. Style, let me see here. Okay, so for this one here, the dataset, you need to have the sample dataset from the geemap repository. So you can either download the entire repository from the geemap, for example, from here, and you can clone the repository to your computer. The dataset is basically under the examples folder and dataset. So for me, I already download this one, but because the dataset is not under the same directory, you can just copy the entire directory and then come back to here. Then let me see here, if I paste my dataset here, right? And so within my data folder, I have the countries straight file, and I might need to actually modify this one just to the dataset directory, and then you can hit one, it should work. Okay, and then just figure. So in this example, we have the Modis dataset, but we also have the country polygons. If you want to create a map that with multiple data layers, then you can follow this example, right? So if you click this one, this is the simple example. You can also change the projection. So if you want some custom projection, you can do that as well, right? So this is how you can create, for example, using different projection. This one is equal Earth, and there are a couple more projection you can choose from. You can, let me quickly go through the example here. This is using the surface temperature data, and you can use different visualization. You can customize the bounding box and create map using different projections. So I have a couple examples in here. You can, for example, to customize the parameters to create a map for the projection that you like. So this is the first one. Second one, this time sometimes might take a little bit longer because basically you are trying to request the dataset from Google's engine and then to do the reprojection. So it might take a while. Okay, so two more examples. And this is the Robinson. And okay, so anyway, you can customize the dataset to any dataset you like and then to create maps like this. You can also change the location of the color bar. What else? You can also create time-lapse animations. So this one might take a little bit longer to run because you can download multiple time series dataset. So essentially, you're trying to create time-lapse animation, but you can have a coordinate grid, you can have a scale bar or other stuff added to the map. So if you want, you can execute this one, and let me just quickly show you what the result look like. And it's going to download all the images from the Google's engine data catalog, and to composite this one as an animation. But this one we have 17 years, but you can customize this one to earlier here, the end year, right? Just to save time, so I just changed to 2000, but you can change to 2020 if you want. And after that, you should be able to create an animation like this easily. And it's going to download all the imagery and then composite them all together. Okay, so now the time-lapse animation has been created successfully. So we can go to the downloads folder and then click time-lapse. You should be able to see this one here, the GF animation. You can double click and then you should be able to see this one, the animation, right? You can have a title, you can have the nose arrow, scale bar, and also the coordinate grid, right? So this is nice if you want to create some animation like this, so they can publish on social media or insert into your website. Okay, so that's about creating maps, and the next section is about export data. You can export an image, or you can export on image collection. You can also export pixels. So let me just quickly go through here. There are a couple ways you can export the data. You can export the data directly to your computer, or you can export data to Google Drive. So if your dataset is a small dataset, you can export data to your local computer. So in this case, we have the Lancet data, right, global scale. But you can simply draw a rectangle somewhere, and then this is the ROI, right? So you basically the user ROI, and then you can set the output directory, for example, the downloads folder, and then set the output file path. Lastly, you can just clip the imagery. It's going to just simply download the imagery to your computer as one file. Okay, so just the Lancet. Then you can open that one using QGIS or ArcGIS. You can also, if there's a multispectral band, you can export it. Each band is one single file. So file per band equal to 2. That means you want to export multiple bands. Each band is one image. Okay, so now you have Lancet, for example, B1, B2, all the way to B7. If you want, you can control place to export this one to your Google Drive, and then you need to log into your Google's Engine account to look at the status of this one. You can also export, for example, the entire image collection, right? So if you have a time series of images, you might want to download those images all at once. So in this case, we have 7 images, right? So you can just use the geemap export image collection. It's going to download those images automatically onto your computer. If you are using the JavaScript, it's very inconvenient because you need to click the button one by one. You need to click the button 7 times in order to download the imagery. But if you're using the geemap, you see everything is automatic, so save you a lot of time. You can also export pixels as a NumPy array. So if you want, you can simply define an ROI and then directly export those as NumPy array. Then you can use those NumPy array for follow analysis. You can also extract, for example, a pixel values based on a swap file or points, right? So in this case, we have the Lancet data, for example, and then if you want to export the pixel values of all the US cities, you can just simply download the sample data set, and then you can change the swap file, convert the swap file to Earth Engine object, and then you can use the object to actually to extract pixel values if you want. So just hit run, DM download to the US cities, DM swap file. Oh, I forgot to execute this code block. So if I execute this one again, and then we should be able to run this one now. So basically, we're trying to extract the pixel values of all the elevation of all US cities. Okay, so now you can turn this one. You can open the swap file on your local computer. You can also export as a CSV if you want. Okay, so we don't have time, so you can execute this one later. If you want, you can also export a feature collection, so basically a vector data, and this is how you can export the dataset from Google's Engine. You can export the vector data to your local computer, or you can export to Google Drive. So you can just use E to SSP to export the data to your computer. You can also export vector to Google Drive. So there are a couple of formats. You can export as CSV, or can also export as JSON or KML. And last section is about developing web apps, and so we don't have time to get into the details. There are two ways you can develop web apps. You can also use Ngrok. So this one, you can use your local computer as the server to host web apps. You can also deploy to Heroku. It has a free version, so you can also utilize. So I have 2 video tutorials that you can watch to follow through if you want to develop web apps. I think each one is like 15-20 minutes, so you can follow through the video. Okay, so that's all for this workshop. I hope you learn something new and useful. And so if you have any question, you can post the question on the GitHub repository, geemap, and then discussions. I'm happy to answer your questions. Okay, thank you so much for attending, and hope to see you in the future videos. Take care. Bye bye.